Hello everyone. Welcome to this quick overview of the fresh water generator on our ship. The system has 4 main pumps: condensate pump, distillate pump, circulation pump, and seawater pump. Now, let's see the most important component of our system, the evaporator that is the core unit. A heat exchanger where seawater is heated and evaporated into vapor. The condenser is the second key exchanger. The distillate pump draws condensed water from the condenser bottom and pumps it to storage tanks. Let's explain the evaporator's role in detail. Seawater enters the evaporator chamber as feed water. Hot water from the main engine's high-temperature HT jacket cooling system flows through tubes or plates inside the evaporator. This transfers heat to the seawater. Because the entire chamber is under vacuum, the boiling point drops significantly, to around 40 to 65 degrees Celsius instead of 100 degrees Celsius. The seawater evaporates into vapor. Here you can see how the HT jacket water from the main engine is diverted directly to the evaporator. It enters through dedicated inlet pipes, passes through the heat exchanger tubes or plates, heats the seawater, and then returns to the engine cooling circuit, efficiently recovering waste heat without extra energy cost. The key to making this work efficiently is depressurizing the evaporator chamber. Here's the vacuum gauge that can reach -0.9 to -1 bar. This level is required for the system to work properly. Once reached, evaporation runs smoothly and efficiently. Now, the role of the condenser. The hot vapor from the evaporator rises and enters the condenser section. Cold seawater flows through the condenser tubes or plates, absorbing heat from the vapor. This cools it below the dew point, turning the vapor back into pure distilled fresh water, which collects at the bottom. Now let's look at the seawater inlet pipe. It brings in cold seawater from the sea chest. This cooling medium passes through the condenser first, often preheating slightly before going to the evaporator or ejector, making the whole system more efficient. The seawater pipes are typically made from corrosion-resistant materials like copper-nickel alloys to handle the saline environment and prevent degradation over time. Back to the distillate pump, it's mounted low to get good suction from the condensed water level. It pumps the fresh water out reliably, usually at 2 to 5 cubic meters per hour depending on the unit size, and includes safeguards like a salinometer to monitor quality and prevent high salinity water from entering the tanks. Here I'm pointing to the delivery pressure gauge of the distillate pump. And this is the flow meter. It measures the rate of fresh water production.